Hi everybody, in this video we are going to talk about radians, which are just another unit of measurement for measuring angles. And I want to start by saying we can choose to measure things using any unit we wish. So for example, how tall is the Empire State Building? Well, if we were measuring the height of the Empire State Building in feet, we would say that the height is 1,454 feet. Okay, so a foot is about this tall, and it would take 1,454 of these stacked on top of each other to get to the top of the Empire State Building. All right, but we don't have to measure height in feet. We could also choose inches. Inches are 12 times smaller than feet, and therefore it would take 12 times more of them to get to the top of the Empire State Building, or whatever it was we were measuring. So if we were measuring the height of the Empire State Building in inches, we would say that the height is 17,448 inches. If we were measuring in meters, which is a little bit more than a yard, a little bit more than 3 feet, then it would take 443 of them to get to the top of the Empire State Building. If we wanted to measure the height in miles, well, the Empire State Building is not even, it's tall, but it's not even 1 mile high. So the measurement in miles would be 0.28 miles. So we can choose to measure things using any unit that we want. There's really nothing special about a foot or an inch or a mile. We just have to pick something and then say how big that something is. Okay, like a foot is about this big, and then measure whatever we're measuring in terms of that thing that we chose. But again, we can choose anything that we'd like. So, that being said, a circle is often split up into units called degrees, and we've been talking about degrees. Each degree is very small, and it takes 360 of them to make a full rotation. Okay, so 1 degree, just 1 degree. Remember, a degree, first of all, when we're measuring angles, what are we measuring? We're talking about the rotation between 2 lines. Okay, so here, my 2 fingers, there's not much rotation between them, then I can rotate this finger a little bit more and then rotate a little bit more. So when we talk about measuring angles, we're talking about the amount of rotation between 2 lines. Okay, so if these 2 lines are pretty close together, then there's not very much of a rotation between them in the first place. And we would call that 1 degree. Okay, and it takes 360 of these little guys to make a full rotation. Okay, but again, a degree is just a unit of measurement. There's nothing special about a degree. We don't have to measure rotations in degrees. And we're going to talk about radians, and then I think in another video why mathematicians prefer to use radians rather than degrees. But right now I just want you to understand that there's nothing special about a degree. You've probably been measuring angles in degrees in middle school, maybe 6th or 7th grade, but you don't have to measure angles in degrees. You could choose another unit of measurement, just like if you're measuring the height of something, you have a lot of different units of measurements to choose from. The number 360 does actually come from somewhere. It has its origins in ancient Babylonian astronomy. And if you're interested, I'll put a link to an article that you can read in the description to this video. But still, there's no reason why we have to continue dividing a circle into 360 equal pieces and calling those pieces degrees. We can split up a circle into however many pieces we want. If we wanted to, we could split a circle up into 100 equal pieces, or 50 equal pieces, or 75 equal pieces, anything. So, what is the number that modern mathematicians have chosen? Well, I'm going to tell you right now. I'm not going to tell you why they have chosen this number. I'm going to save that for another video. Right now, I'm just going to tell you the number that they have chosen. So mathematicians choose to split a full rotation up into 2 pi, which is about 6. Remember, pi is approximately 3, right? So 2 pi is about 6. So modern mathematicians have chosen to split a full rotation into 2 pi equal pieces, and each of those pieces is called a radian. So this, the amount of rotation that you see right here between these two lines, that is obviously, first of all, it's much bigger than a degree, right? A degree was a tiny thing. This is a lot bigger, and it only takes about 6 of these to get all the way around the circle. So this is 1 radian, 2 radians would be about here, 3 radians about here, 4 radians would bring us about here, then 5 radians about here, and then 6 radians would bring us almost back to where we started. Remember, it takes exactly 2 pi radians, which is a little bit more than 6, to bring us exactly where we started. 6 radians would bring us about here, and then 2 pi radians, which is 6.28 something, that would bring us right exactly back where we started. So that's what a radian is. And for the rest of this video, I'm just going to talk about how to convert between radians and degrees. And let's start with just 1 radian. So this radian right over here, how many degrees is this? So 1 radian is equal to how many degrees? And the way to answer that is actually pretty simple. You've converted units before between inches and feet, or miles and meters, or whatever it was. This is really no different. The way that we're going to do this, there are different strategies. The strategy that I'm going to use is to set up a proportion. So what I'm going to do is to convert between radians and degrees, you can set up a proportion with 2 pi and 360 in the denominators. So for example, let's just start setting up our proportion by writing a fraction over here and over here, putting an equal sign between them. I'll put 2 pi over here, I'll put 360 over here. Now I want to know 1 radian is equal to how many degrees? So that was 1 radian. I'll put that here in this fraction with the 2 pi. Okay, so whatever is radians, I'm going to put that in the fraction with the 2 pi. And whatever is degrees, I'm going to put that in the fraction with the 360. I'm looking for the number of degrees that's equal to 1 radian. I don't know that number yet, so I'm going to put an x over here. And then I would just solve the proportion. Okay, so I would do 360 times 1 is 360 equals 2 pi x. All right, 2 pi times x, so 2 pi x. And then to figure out what x is, I would divide both sides by 2 pi. All right, and so that would cancel out over here, and then I would get x equals 360 divided by 2 pi. Now you have to be careful here. I'm going to go over to the desmos.com/scientific calculator. You do have to be careful. If I were to just put 360 divided by 2 pi, oh, actually, in this calculator, I think it's okay. Yeah, I could. In this calculator, it's all right. I can divide by 2 pi. Where's the pi? Do they have a pi? Oh, I hope they have a pi. Wait a minute. Oh, here it is. Okay. No, that's not good. I want the pi to be in the denominator. Okay, good. So I would get approximately 57.29 blah, 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 blah. So let's say about 57.3 degrees if I round to the nearest tenth there. Okay, approximately. All right, so 1 radian is about 57.3 degrees. I'll just type that in here. Okay, let's do some other examples. How many radians would be the same as 30 degrees? So 30 degrees is actually, so 1 radian is more than 30 degrees, right? 30 degrees would be about here, right? So this would be about 30 degrees, okay? So let's just do it. Let's set up our proportion. I'll put 2 pi over here, 360 over here. This time I know the degrees, so I'll put that over here with the 360. I don't know the radians, so I'll put an x over here. And then let's cross multiply. So 30 times 2 pi would be 60 pi. And x times 360 gives me 360x. And then divide both sides by 360. So we would get x equals 60 pi divided by 360. Go over here to find the pi. All right, then divide by 360. Okay, and that's going to give me 0.5. Okay, about 0.5. Which does seem like a reasonable answer. Okay, this is approximately 0.5. Seems reasonable because 30 degrees is about this. This is about 30 degrees over here. And you can see that that's about half of 1 radian. So 0.5 as an answer makes sense. All right, let's do a couple more. For this one, pi radians is equal to how many degrees? So pi is 3.14 blah, 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 blah. So a little bit more than 3 radians, okay? Pi radians, how many degrees would that be? So we'll do pi over 2 pi equals x over 360, since we're looking for the degrees now. Now the pi and the 2 pi cancel out immediately. So I could rewrite this whole proportion as 1 over 2 is equal to x over 360. If you're not sure where that 1 came from, hopefully you agree that pi is the same as 1 times pi. All right, so when the pi's cancel out, then the 1 is still there. So now we have this proportion to solve, and that's going to give us 360 equals 2x, and then divide both sides by 2. So in this case, x is exactly equal to 180. So pi radians is equal to 180 degrees. All right, now that also makes sense because remember, radians were defined so that 2 pi of them would be a full rotation. So it takes 2 pi radians to make a full rotation. So 1 pi would be only half a rotation. If it takes 2 to make a full rotation, then 1 would only get me halfway. Not 1 radian, but 1 pi radians would only bring me halfway, which is 180 degrees. So hopefully that makes sense. Now, how many radians are equal to 90 degrees? Let's figure that out. Actually, if you want to pause the video and try figuring that out based on our answer to this problem, you might be able to do it. But I'm just going to go ahead and set up the proportion now. So I want to know how many radians are equal to 90 degrees. So I'll put the x with the 2 pi and the 90 with the 360. 2 pi times 90, 2 times 90 is 180. So I'm going to get 180 pi over here. 360 times x will give me 360x. And then I will divide both sides by 360. Okay, now you could go to the calculator over here, but also you could just simplify this fraction. 180 over 60 is the same as a half, same as 1 over 2. I could divide the numerator by 180 and divide the denominator by 360. If I ignore the pi for a second, if I divide the numerator and the denominator by 180, then 180 divided by 180 is 1, and 360 divided by 180 is 2. So I can simplify this fraction to be just 1 over 2. But don't forget the pi was there, right? So this is actually 1 pi, which is just the same as pi. Okay, so actually I don't need the 1, and I can rewrite this again as simply pi over 2. So 90 degrees is equal to pi over 2 radians. Oh, now I got to use this thing over here. There we go, I got it. That didn't take too long, right? So 90 degrees is the same as pi over 2 radians. Hopefully that makes sense to you based on our previous answer, because we said that 180 degrees was pi radians. So 90 degrees is half of 180 degrees. Okay, so if 180 degrees was pi radians, then 90 degrees should be half of pi, or pi over 2 radians. Okay, so again, it's relatively simple to convert between radians and degrees, just like converting between any units. You can set up a proportion and then cross multiply and divide and get the answer that way. Now I'll finish up the video just by mentioning that there are some conversions that you should be familiar with. Okay, so you should know, just like you know your times tables for certain numbers. Hopefully you don't have to go to a calculator every single time you need to do 2 times 2, right? There are some measurements in radians that you should know off the top of your head how to convert them into degrees. You should just know what they are in degrees. You can convert back and forth. Okay, so pi, 2 pi, pi over 2, pi over 3, pi over 4, and pi over 6, and multiples of those numbers. So for example, not just pi over 3, but also 2 pi over 3, which would be a multiple of pi over 3. You should know those. Okay, so let's start with pi. We already did pi a few minutes ago. Pi is 180 degrees, right? So if I started over here and I rotated all the way over here, then if I wanted to measure the rotation in degrees, it would be 180. So pi radians is the same as 180 degrees. What about 2 pi? Well, if pi is 180 degrees, then 2 pi would be 2 times 180 degrees, or 360 degrees. And of course, we already knew that because we defined radians so that 2 pi of them would be a full rotation. And we know that a full rotation measured in degrees is 360 degrees. So 2 pi radians is the same as 360 degrees. What about pi over 2? Well, that would be half of pi. So that would be half of 180 degrees, which is 90 degrees. So the rotation from here to here would be 90 degrees, or pi over 2 radians. And now that we have a fraction, now let's start talking about multiples. So if pi over 2, or another way of me saying that is 1 pi over 2 is 90 degrees, then 2 pi over 2's, or 2 pi over 2, should be 180 degrees. And that makes sense because 2 pi over 2. So if I have pi over 2 but 2 of them, then that's the same thing as just having pi, which we already said was 180 degrees. So hopefully that makes sense. If pi over 2 radians is 90 degrees, then 2 pi over 2's would be 180 degrees. And 2 pi over 2's is the same as just 1 pi. 2 halves of pi is the same as 1 pi. All right, so if I add another pi over 2, then now I have 3 pi over 2. Okay, 3 halves pi is the same thing as writing 3 pi over 2. And that would be another 90 degrees added to this. So 180 degrees plus another 90 degrees is 270 degrees. Okay, and then if I were to add another pi over 2 radians, all right, so So now I have 4 pi over 2. Then 4 divided by 2 is 2. That's the same thing as, well, I shouldn't be canceling these out, actually. 4 divided by 2 is the same as 2. So this is equal to 2 pi, right? So if I have pi over 2 4 times, then pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is just the same as 2 pi, because 4 divided by 2 is 2, then that's 360 degrees. From this 270 degrees, or 3 pi over 2 radians, if I add another pi over 2 radians, which is 90 degrees, then I would get 360 degrees. Okay, now pi over 3, here it is in the picture here, pi over 3 is 60 degrees. We didn't do that one yet, but if you wanted to set up the proportion, then here's how you could do it. That might look a little bit strange, so I'll show you how you could do that one. You could put pi over 3 in the numerator and then x over here. All right, now, if I have a fraction over another fraction, then actually that's the same thing as taking this denominator and multiplying it by this. So I can rewrite this as pi over, and then 3 times 2 is 6. So this is the same thing as 6 pi. Okay, so pi over 3 over 2 pi is the same thing as pi over 6 pi. Then I have equals x over 360. The pi's cancel out, so I have really just 1/6 is equal to x over 360. And then I could cross multiply, and you would get 6x equals 360. And then divide both sides by 6. Okay, so x is equal to 60. And of course, the x is in degrees, right? So pi over 3 radians is equal to 60 degrees. I'm not going to do that for every one of these, but I just wanted to give you one example of how you could use a proportion to convert from radians to degrees when the angle in radians was in the form of a fraction. Okay, just remember that you can take this denominator here and sort of bring it into this denominator. Just multiply this by this coefficient over here. Okay, so anyway, pi over 3 is 60 degrees. If I add another pi over 3, now I have 2 pi over 3. That would be 120 degrees because I'm adding another 60 degrees to 60. Okay, if I go another pi over 3 radians, then I would be going another 60 degrees. So 120 plus 60 is 180. And by the way, so I did pi over 3 3 times. So now what I have is 3 pi over 3, and the 3's cancel here. So I have just pi. So, and you can see that in the picture, that is where I'm at, okay? So if I do pi over 3 3 times, then I would just be at pi radians, which is 180 degrees. If I add another pi over 3 radians, then I would be adding another 60 degrees over here. So I would be at 4 pi over 3, or 4/3 pi is another way of writing it. Okay, that would be another 60 added to 180 is 240 degrees, and so on. If I add another 60 or another pi over 3, so now I'm at 5 pi over 3 radians, 300 degrees. Okay, and then finally 6 pi over 3. So going from 5 pi over 3, adding another pi over 3, now I'm at 6 pi over 3, but 6 divided by 3 is 2. So that's really the same thing as 2 pi, which we said before was 360 degrees. And you can see it makes sense again here because we see that we were at 300 degrees back here. If I add another 60 to this, because pi over 3 radians is 60 degrees, then I would be at the 300 plus 60 is 360 degrees. All right, let's go ahead and do pi over 4. So pi over 4 is half of pi over 2. A fourth is half of a half. So if pi over 2 is 90 degrees, then pi over 4 should be 45 degrees. Okay, so this rotation is pi over 4 radians or 45 degrees. You know what? I'll give you one more example real quick of converting this. When that's a fraction, how do I how do I put it into a proportion and figure out the degrees? Well, I can do 4 times 2 pi is 8 pi. So I can rewrite this whole thing as pi over 8 pi equals x over 360. These pi's cancel. I could put a 1 there. And then 8 times x is 8x. 1 times 360 is 360. Could divide both sides by 8 here. And then you get x equals 45. Okay, just do the long division there or put it into a calculator and that'll give you 45. Okay, so if I add another pi over 4, then 45 plus 45 is 90 degrees. And of course, pi over 4 plus pi over 4 is the same as 2 pi over 4. And that you can reduce to a half, right? And you can so you can rewrite this as pi over 2, which of course it is over here in the picture. Okay, so if you keep adding pi over 4 radians, then that's like adding 45. Whoops, I think I pointed to the wrong one there. Okay, if you keep adding pi over 4 radians, then that's like adding 45 degrees. Okay, I'm not going to go around the entire circle this time, but you would have 3 pi over 4, 4 pi over 4, the 4s would cancel, that's the same as pi, 5 pi over 4, 6 pi over 4, 6 over 4 reduces to 3 halves, right? So 6 pi over 4 is the same as 3 pi over 2. And then we would have 7 pi over 4, and finally 8 pi over 4. Well, 8 divided by 4 is 2. That's the same as 2 pi, which is 360 degrees. All right, so, all right, and you would just keep adding 45 degrees if you wanted to keep going around this circle. And finally, the last one, pi over 6. Pi over 6 is the same as 30 degrees. That's actually one of the examples we did earlier. We said 30 degrees was approximately, this was not exactly, but approximately 0.5 radians. So this should kind of make sense. Because what's pi over 6? Well, pi is approximately 3. So pi divided by 6 should be approximately a half, because 3 divided by 6 is about a half. Well, 3 divided by 6 is exactly a half. So something which is about 3 divided by 6 should be about a half. All right, so that's the same answer that we got before. And this, we're just going to do the same thing that we've done. If we keep adding pi over 6, pi over 6 plus another pi over 6 would be 2 pi over 6. But 2 pi over 6, 2/6 is the same as 1/3. So 2 pi over 6 is the same thing as pi over 3. And we already said that pi over 3 was 60 degrees. And again, we can see that this, it all makes sense. It's all consistent because 30 plus another 30 also gets me to 60 degrees, right? So it all works out. If I add another pi over 6, now I'm at 3 pi over 6. But 3 over 6 is a half, so this is the same thing as pi over 2, which we said was 90 degrees before, right? And of course, if we add another 30 degrees to 60, then we do get 90 degrees. All right, and so on and so forth. So we're at 3 pi over 6 right now, which is the same as pi over 2. Then we could go to 4 pi over 6, which is the same as 2/3 pi, or 2 pi over 3, and then 5 pi over 6, and then 6 pi over 6, which is the same as pi, 7 pi over 6, 8 pi over 6, 8 over 6 reduces to 4 over 3. What are we at now? 9 pi over 6, 9 over 6 reduces to 3 over 2, 10 pi over 6, 10 over 6 reduces to 5 over 3, 11 pi over 6, you can't reduce that, 12 pi over 6, all right, 12 divided by 6 is 2, so that's the same as 2 pi. That's counting by pi over 6 for the radians, or we could do the same thing counting by 45 degrees Okay, 90 degrees, 135 degrees, 180 degrees, 225 degrees, and so on and so on and so on. All right, so you can just keep going around the circle that way. All right, I think I'm going to end the video there. Have a great day.